Okay, so today we're going to start off with multiplying radicals. Okay, so this differs from adding and subtracting radicals, much like adding and subtracting fractions differs. So let's quickly review. So adding and subtracting radicals that have the same number under the radical, so the same radicand. If you had 2 radical 3 plus 5 radical 3, you can add them together and get 7 radical 3. So you add the numbers on the outside, the coefficients on the outside, and then you keep the number under the radical. When you are multiplying fractions, if you have 2/3 times 1/4, when you're multiplying, you do not have to have the same denominator. So 2 times 1 gives me 2. 3 times 4 gives me 12. Like all fractions, make sure that you can or cannot reduce. 2 goes into both of these, so I end up with 1/6. So multiplying fractions, you do not have to have the same number in the denominator. Same thing with multiplying radicals. So if we have 2 radical 3 times 1 radical 4, we can multiply the numbers outside and get a new number outside, and multiply the numbers under and get a new number under. So we end up with 2 radical 12. Like fractions, you have to make sure that this cannot be simplified, and it can. Square root of 12 gives me 2 radical 3. I cannot forget about the 2 that I already have, so I have 2 times 2 radical 3, which gives me 4 radical 3. Okay, so let's look at example 1. I have 6 radical 10 times 2 radical 15. The nice thing about radicals is much like exponents is that as long as you're not breaking any math rules, the order of what you do doesn't really matter. So I could simplify this, or I could go with what I just did up here and multiply both numbers on the outside and get 12, and then multiply both numbers under and get the square root of 150. So I have 12 radical 150. Again, I have to make sure that this cannot be simplified, and it can. So I have 25 times 6, 5 times 5 times 6, circle my pairs. So I have 5 radical 6. Do not forget about the 12 that I already had there. So I get 60 radical 6. Okay, look at another one. Example 2, I have square root of 15 squared. So you have to think about what that squared actually means. It means I have 2 of these. So I have the square root of 15 times the square root of 15. You could multiply them together and get the square root of 225. And then simplify 225. Now if you think about it, you're going to end up with 15 times 15. Circle your pairs, and one of them comes out with a nice neat 15. You can do this with understanding that the square root of 15 squared, square rooting and squaring are inverse operations, so they undo each other. So you're left with 15. Another way of doing it. You could have at the same time done square root of 15 times the square root of 15 and broke down your pairs, circled your pairs, take one number out from each pair and you still get a 15. So So there's three ways of thinking about doing the same exact problem. You need to think about what squaring actually means. Example 3. You are going to see some things that we did a couple chapters ago with, let's do the square root of 3 times a quantity of 4 radical 2 minus radical 6. What you have to recognize here is that this is the distributive property. So you are going to take the square root of 3 times this first term. This is where you really have to keep your mind straight as far as what it is that you're multiplying. So I am multiplying square root of 3 times 4 radical 2. 4 is the only thing outside the parentheses, so I have a 4. Radical 3 times radical 2 gives me radical 6. Now I'm going to multiply the radical 3 times negative radical 6. Again, they are under, so if I multiply them, that number has to stay under. Like fractions, like radicals, you always have to check to see if something can be simplified. And this certainly can. I end up with 3 times 3 times 2 gives me 3 radical 2. I want to bring down my 4 radical 6 minus the 3 radical 2. I'm thinking I have to add or subtract. If I add or subtract, I have to have the same number under the radical. These aren't. So I'm done. Last example. Okay, lots of stuff happening here. Again, you really have to keep it straight as far as what you're doing. If you're multiplying, you multiply the numbers under the radicals. If you're adding, you can't. So you really have to keep it straight. So we're doing the distributive property again, or FOIL. So in my mind, I'm doing 3 radical 5 times 2 radical 5. So if I'm multiplying, numbers outside stay outside. Numbers under stay under. I get 6 radical 10. Next, I'm going to do the outers. So again, I'm using the distributive property. 3 radical 5 times 3. Both of these 3's are outside the radical. So I can multiply them together. This is radical 5. There's no radical here, but that doesn't matter. It is still just radical 5. Next, I do my inners, again distributing. So I have negative 2. Radical 8 times 2 gives me 16. And then finally, I'll get a different color. Negative 8 times, negative radical 8 times 3 gives me a negative 3 radical 8. Square root of 10, that is simplified because it's just 2 times 5. There's no pairs to pull out. That's simplified. Square root of 16, that is a nice, neat 4. So this gives me something different. And then radical 8 gives me 2 radical 2. So I'm going to clean this up. This is already simplified. This one's already simplified. Square root of 16 is 4. So 4 times a negative 2 gives me a negative 8. And then I have negative 3 and the 2 are on the outside. So I get negative 6 radical 2. I have to look one more time. And if you notice, these are like terms. So 6 radical 10. Combining those, I get 3 radical 2, and then I have my minus 8. That would be my final simplified answer.